Now that we know how to find edges in an image, we want to go from those edges to clean outlines or silhouettes of objects in the image. This is the problem of boundary detection. So essentially, we want to go from edge pixels to object boundaries. The first topic we're going to talk about is fitting lines and curves to edges. So you're given a set of edges in the image, and you want to fit essentially a low-order polynomial to these edges. And so we'll see how this can be set up as a system of linear equations, and how such a system of linear equations can be solved very efficiently, very robustly. Next, we'll talk about active contours, also known as snakes. These are widely used in computer vision, in particular in fields such as medical imaging. So imagine that you have an object in an image and you want to find its boundary. Now, the image, of course, has a variety of other things inside of it. So what you do in this case is you sketch a very rough outline of this object, just outside of it. It could even be done by hand. And now what you want to do is take this contour and iteratively modify it or deform it so that ultimately it goes and latches on like a rubber band to the actual boundary of the object. So we'll see how we can set up the problem of active contours and how we can compute them efficiently. Now, in boundary detection, a really hard problem is figuring out which edges belong to the boundary that you're looking for. So you have sort of an inlier-outlier problem. And this technique called the Hough transform, very clever technique invented in the 1960s, gives you a very elegant way of solving the inlier-outlier problem. And so we'll describe the Hough transform and how it can be set up to find very simple geometric forms such as lines and circles very effectively in very complex images. And then we'll finish up with the generalization of the Hough transform. What if you're not given the parametric form of the thing that you're looking for? What if it's actually a hand-drawn sketch, a shape? Well, it turns out you can actually generalize the Hough transform to apply it to those kinds of complex shapes as well, and we'll see how that kind of a technique can be implemented and what the limitations of the generalized Hough transform are.